Hello students, in this class I am going to discuss about a very short topic, but the topic is very interesting. The topic is regarding current electricity. It is about the flow of electric current in a circuit where some resistances are there, some sources of electromotive force are there, and the current when flows through those resistances, definitely some energy gets consumed in those resistances for which the total amount of energy provided by the source of EMF will be reduced. And the rules of all these reductions of energy, as well as the rule of flow of current, the relations between the current, resistances and the EMFs, were being discussed and explained by a German scientist, Gustav Kirchhoff. According to him, there are two laws. One is called Kirchhoffs Current Law. The other one is called Kirchhoffs Voltage Law. Sometimes it is also called law of loop. Anyway, when we are discussing about Kirchhoffs Current Law, it is regarding to a number of currents which flow in and out about a junction. Suppose there are two lines through which two currents get in to the junction, and there are three lines through which three currents get out. According to him, the total energy at this junction was zero before entering these currents I1 and I3, and will become also zero after getting out of these currents I2, 4, 5. That means there will be no energy before the current flows in and no energy after the current gets out. That means this statement resembles the law of conservation of energy. So according to him, if we consider those currents which gets in are to be taken as positive and which gets out are to be taken as negative, sum of all these currents get in and get out will be zero. This can be also written as summation of all current is zero. The application of this law is considered in various numericals, but more important law is this one, Kirchhoffs Voltage Law. According to this, his statement was in a closed loop. Mind it, the loop should be closed. Now, in the current law, when we draw like this, many circuits are open. Many circuits are open, but in this case, the circuit will start and end, so that a closed loop can be formed. In a closed loop, the sum of the products of, there are various resistances in the circuit, so we have to take in those resistances considered. Look, the sum of the products of resistances and the currents corresponding to those. Okay, we may sort this statement, and the corresponding currents, the products of resistances and corresponding currents, and the EMFs. So, whose sum are to be taken? The sum of the products of resistances and corresponding currents and the EMFs. Is 0. Suppose, let's take an example like this. Suppose there is an EMF of E1. This is an EMF of E2. Suppose this is E2, this is E1. This is R1, R2, R3, and this EMF generates a current of I2, this I1. This I1 flows along this path. Here it joins with I2. So this path carries a total current of I1 and I2, which flows through this resistance of R3. This current flows through the resistance of R2. This current flows through the resistance of R1. Mind it, the current which flows out of a source must join that source, must join that very source at a time. So here I1 plus I2, after reaching this junction, I1 gets separated and flows into the source E2, and this is I2. I1 continues flowing, which ultimately ends at E1. So I1 out, I1 in, I2 out, I2 in. You have to take, when you apply the Kirchhoffs rule, Kirchhoffs Voltage Law, you have to take one loop at a time. Suppose let's name them A, B, like this. When you take this loop, in loop B, C, D, E, B, you have to complete the name from up to the starting point. In loop this, when you see that the current goes out in conventional way, that means the arrow is given in the diagram in traditional manner, then you have to take the product of this current and resistance as negative. Why? Because we know V is equal to IR. That means this is the potential. When this current flows through this resistance, some amount of energy is consumed by this resistance, and that energy is lost ultimately by this source. From this source, the current flows out as I2, and when this current ultimately travels all along and pass through this resistance, then the product of these two, this I2 and R2, will be that energy which is consumed inside this resistance and is lost from this source. That means this cell is now discharging. It is losing the charge. You know, when the phone, our phones are kept in charge, and after the charge is full, when we use the phone all through the day, the cell battery, the phone battery, actually losing the energy. It loses the charge, which actually in the form of energy is stored inside. That energy is the product of current and resistance. So we have to reduce that amount of energy from this EMF. So we have to write as this EMF minus I2R2. Similarly, the sum of these two currents, I1 and I2, flows through R3. That means here also some charge gets reduced, some charge gets used up by this resistance. So that energy also is being lost by this source. So that product will also be reduced from this source. So here I1 plus I2 into R3. So this is the cell EMF. This is first losing of energy. Some amount of energy is lost in R2. Some amount of energy is lost in R3. And according to him, the sum of all EMFs and the products of resistances and corresponding currents will be 0. Now in loop A, B, E, F, A. A, B, E, F, A. While you considering one loop, you have to ignore the other loop such that it is not present there. Just not taking it considered. Taking this loop. Now there is a problem. What is that? There are two EMFs. Now when you see that there are two EMFs or more than one EMFs in a closed loop, then you have to understand which one is greater. Suppose in this case E2 is, let's take E2 is greater than E1. When this happens, the current provided by E2 will dominate I1 provided by E1. Since this is less voltage than this, suppose let's consider E2 is 10 volt, E1 is 6 volt. Since it is 10 volt, it is 6 volt, so the current provided by this source will be greater than the current provided by this source. Since you are not considering this loop, so this current has to move this way and this current has to move this way. But since this source is more than this source, so this current is stronger than this current, so this current will dominate this current. As a result, in practical situation, the direction of I1 will be reversed. Although in the diagram I1 is shown this way, but in practical application you have to take in I1 this way, and for this reason I1 is to be in charged condition. That means E2 is taken to be discharging and E1 is taken to be charging. When a cell is being charged, that means energy is being added to that cell. Here the energy is spent out, energy is lost. So this I2 R2 is taken as negative, but this I1 R1 is taken to be positive. So in this case we have to write E2 minus I2 R2, but in this case I1 R1 is taken to be added to E1. Now since the current is in reverse direction in this cell, inside this cell, since current is from positive terminal towards negative terminal, inside the cell when the current is from positive to negative terminal, it is taken to be negative. Sign convention for cell is what? When you see this is taken to be positive, but when you see this is taken to be negative. When the cell is in charged situation, that means energy is added, the current inside the cell flows from positive to negative, then it is taken as negative, and if it is in reverse condition, inside the cell it is negative to positive, then it is taken as positive. So here in this case, I1 is taken to be negative and I1 R1 is taken to be positive, since this energy, the product of this current and resistance, this energy is added to the cell E1 and the net sum will be 0. You can use this rule for solving several numericals.